The observation deck of the Zorn Collective's reconnaissance vessel hummed with quiet anticipation. Holographic displays flickered with intricate data streams, painting a complex portrait of the blue-green planet below. Earth looked deceptively peaceful from orbit, a marble of swirling blues and greens, punctuated by white cloud formations and the glinting metallic structures of human civilization. Captain Zaxrill adjusted the sensitivity of his neural interface, zooming in on the planet's surface. His four membranous eyes, each capable of processing multiple spectrums of electromagnetic radiation, narrowed with a mixture of contempt and mild curiosity. Humanity represented an anomaly in the Galactic Concordance's comprehensive stellar database, a species that seemed perpetually on the brink of self-destruction, yet simultaneously possessed an inexplicable capacity for rapid technological adaptation. "Preliminary scans complete," announced Analyst Krelev, their voice a low resonant hum that translated perfectly through the ship's communication systems. "Technological development significantly fragmented. Infrastructure inconsistent. Potential for interstellar communication minimal." Zaxrill's tentacle-like appendages, each serving as both a sensory organ and a complex manipulation tool, danced across the holographic controls. Layers of planetary data unfolded before him, economic systems that seemed to operate on unpredictable market fluctuations, communication networks that appeared chaotic yet somehow functional, and technological ecosystems that defied traditional linear progression. In Houston, Texas, Jack Hawthorne stood before a wall of monitors, completely unaware of the alien scrutiny. His workspace was a controlled chaos minus 3D printed prototypes hung from magnetic strips. Complex circuit boards lay partially disassembled, and multiple computer screens displayed overlapping schematics and simulation results. A half-empty coffee mug balanced precariously near a stack of research papers. Handwritten notes covered the margins, filled with equations, diagrams, and observations that seemed to follow no conventional scientific methodology. To an outside observer, it would look like the workspace of a madman. To Jack, it was the nexus of humanity's most revolutionary engineering approach. "System recalibration complete," he muttered to himself, fingers dancing across multiple keyboards. 3 separate computer systems worked in tandem, running complex simulations that pushed the boundaries of adaptive engineering. His latest project focused on creating modular technological systems that could rapidly reconfigure themselves based on environmental challenges. The Zorn Collective scanners continued their meticulous analysis. They cataloged humanity's technological landscape, a bewildering array of cutting-edge research existing alongside seemingly antiquated systems. Nuclear power plants stood near experimental fusion reactors. Quantum computing laboratories were located mere kilometers from factories using manufacturing techniques unchanged for decades. Recommendation: Zaxrill prompted his analytical team. Krelev's response was immediate and clinical. Minimal engagement protocol. Classification: emerging technological civilization. Projected timeline for meaningful interstellar communication: approximately 287 standard galactic cycles. What the aliens failed to understand was the fundamental nature of human innovation. Each seemingly disparate technological system represented a potential building block for something extraordinary. Where alien civilizations saw rigid specialization, humans saw opportunity for radical recombination. Jack Hawthorne represented the epitome of this approach. His current project challenged every established engineering principle in the Galactic Concordance's comprehensive database. He was developing a modular adaptive system capable of restructuring itself in real time, drawing inspiration from biological adaptation mechanisms, quantum computing principles, and unconventional material science. On the alien vessel, additional data streams continued to parse human technological developments. Military research facilities developed next-generation communication systems. Private corporations pushed the boundaries of materials engineering. University laboratories explored theoretical concepts that most established civilizations would consider pure fantasy. Zaxrill made a dismissive gesture, closing several holographic windows. Preliminary assessment complete. Nothing of significant interest. Little did he know that humanity was about to prove him catastrophically wrong. In that moment, as alien sensors completed their initial survey, Jack Hawthorne looked up from his work and smiled. Something was coming. He could feel it in the intricate dance of possibilities represented by his latest prototype. The universe was about to learn that humanity's greatest strength wasn't its technology, but its ability to reimagine what technology could be. The first warning came as a microscopic fluctuation in stellar radiation, so subtle that most monitoring systems would have missed it entirely. But Jack Hawthorne's prototype detection network caught the anomaly instantly. Klaxons erupted across multiple research facilities simultaneously. Jack's fingers flew across holographic interfaces, pulling up real-time data streams from observatories around the globe. Something was happening, something massive and unprecedented. In the orbital observation platforms of the Galactic Concordance, chief astronomers began to realize the scope of the impending disaster. A gamma-ray burst of unimaginable intensity was building, gathering energy in a way that defied every known stellar physics model. "This is impossible," muttered Dr. Elena Rodriguez, head of the Global Catastrophic Risk Research Center. Her team had been tracking unusual stellar activity for months, but nothing prepared them for this. The gamma-ray burst originated from a complex binary star system approximately 1,200 light-years from Earth. Most advanced civilizations would have seen it as a distant astronomical event. Jack Hawthorne saw it as something else entirely, a complex system waiting to be understood. Alien communication networks began to collapse first. The Zorn Collective's most advanced quantum communication grid, a technology they had spent millennia perfecting, began to disintegrate under the intense radiation. Entire planetary networks went dark within milliseconds. Civilizations that had considered themselves technologically invincible found themselves suddenly, terrifyingly vulnerable. Jack's prototype adaptive monitoring system did something unprecedented. Instead of simply recording the catastrophic event, it began to analyze the radiation patterns, attempting to understand the underlying mechanisms of destruction. "We need to model the radiation cascade," Jack muttered to his small team of researchers. They worked with a frantic intensity, pushing computational boundaries that most scientists would have considered impossible. The Galactic Concordance was in chaos. Hundreds of advanced civilizations watched helplessly as their most sophisticated technological systems failed. Planetary defense networks collapsed. Communication infrastructures crumbled. Entire star systems found themselves cut off, isolated, facing potential extinction. In the research facility in Houston, Jack's team discovered something extraordinary. The gamma-ray burst wasn't just a destructive event. It was a complex system of energy transfer that followed specific, albeit incredibly complex patterns. "It's like a massive universe-scale algorithm," Elena Rodriguez observed, studying the data streams Jack's system was generating. Every burst of radiation follows a pattern, chaotic, but with an underlying structure. Most scientific teams would have been overwhelmed. Jack's approach was different. Where others saw destruction, he saw an opportunity to understand, and potentially solve, an unprecedented challenge. The Zorn Collective's most advanced predictive models failed spectacularly. Their technological paradigms, built on millennia of specialized development, couldn't adapt to the rapidly changing stellar environment. Each of their systems was designed for specific, predictable scenarios. This was anything but predictable. Jack's prototype, by contrast, was designed with unpredictability in mind. Drawing inspiration from biological adaptation mechanisms, neural network learning, and quantum computational theory, the system began to map the radiation patterns in real time. Global communication networks began to fail. Satellite systems collapsed. Power grids experienced unprecedented disruptions. But Jack's team continued their work, creating adaptive models that could potentially mitigate the catastrophic radiation effects. "We're not just recording this," Jack told his team. "We're going to find a way to survive it." The gamma-ray burst intensified. Astronomical models suggested complete stellar system collapse was imminent. Most civilizations would have surrendered to the inevitable. Jack Hawthorne and his team saw something else, a complex problem waiting to be solved. As alien civilizations trembled on the brink of extinction, humanity was preparing to do what it did best: reimagine the impossible. The universe was about to learn that technological survival wasn't about having the most advanced system. It was about the ability to adapt, to reimagine, to transform in the face of total destruction. And Jack Hawthorne was going to prove that, one impossible solution at a time. The research facility looked like controlled chaos. Holographic displays cascaded with impossible equations. Circuit boards hung from magnetic strips, connected by a web of experimental neural interfaces. At the center of it all stood Jack Hawthorne, a man whose vision defied every conventional understanding of engineering. "We're not just building a system," Jack explained to his core team of 6 researchers. "We're creating a living blueprint for survival." Dr. Maya Patel, a quantum computing specialist, adjusted a complex array of quantum processors. Her fingers danced across holographic interfaces, combining technologies that most research teams would have considered fundamentally incompatible. Biological adaptation algorithms merged with quantum computational matrices. Nanoengineering intertwined with predictive maintenance systems. The prototype took shape as something between a technological marvel and a biological organism. Traditional engineering saw systems as static, rigid structures. Jack's approach treated technology as a living, breathing entity capable of constant adaptation. "Look at this," Jack said, pulling up a holographic model that seemed to breathe and pulse with its own internal logic. The system could reconfigure itself in real time, drawing inspiration from biological immune systems, neural network learning patterns, and quantum computational principles. Each component was designed with multiple potential configurations, where alien technologies specialized. This prototype generalized. It could transform its fundamental structure based on environmental challenges, learning and adapting faster than any known technological system. The Zorn Collective's monitoring networks, still operational despite the ongoing stellar catastrophe, intercepted fragments of the research. Their most advanced analysts ran complex simulations, desperately trying to understand the human approach. "This is mathematically impossible," proclaimed lead analyst Krelinx, reviewing the intercepted data streams. The aliens' multiple neural interfaces worked overtime, trying to comprehend the radical design. But impossibility was precisely Jack Hawthorne's specialty. The prototype drew power through an unprecedented energy transfer system. Traditional power sources relied on consistent, predictable energy flows. This system could harvest and redistribute energy from multiple sources simultaneously, adapting its collection method based on available resources. Maya Patel showed Jack a critical breakthrough. "Watch this," she said, initiating a simulation that would have been considered pure fantasy in any other research facility. The holographic model began to shift. What started as a complex computational network suddenly began to reshape itself. Circuits reconfigured. Computational pathways reorganized. The entire system adapted to a simulated environmental challenge in milliseconds, a process that would take most advanced civilizations decades of careful engineering. "It's alive," Jack whispered, though alive was perhaps the most inadequate description possible. The Galactic Concordance's most advanced research teams watched in horror and fascination. Humanity was doing something unprecedented, treating technology not as a static tool, but as a dynamic, evolving system. Each failure became an opportunity. Each breakdown transformed into a chance for radical redesign. The prototype didn't just solve problems, it reimagined the very concept of problem solving. Dr. Rodriguez joined the team, bringing her expertise in global catastrophic risk management. "This isn't just a technological solution," she observed. "This is a fundamental reimagining of how systems interact with challenges." Jack's team worked around the clock. They pulled inspiration from seemingly unrelated fields: biological evolution, neural network learning, quantum computational theory, and adaptive ecological systems. Where traditional engineering saw boundaries, they saw opportunities for radical integration. The Zorn Collective's analysts ran thousands of simulations. In every single scenario, the human prototype should have failed spectacularly. Mathematical models proved its fundamental impossibility. They were about to be proven catastrophically wrong. As the stellar catastrophe continued to rage across distant star systems, Jack Hawthorne's prototype represented something more than a technological solution. It was a statement, a declaration that humanity's greatest strength wasn't superior technology, but the ability to see beyond established limitations. "We're ready for the next phase," Jack announced to his team, a smile playing across his lips. The universe was about to learn that impossibility was just another challenge waiting to be solved. The Galactic Emergency Council convened in a moment of unprecedented desperation. Holographic representations of dying civilizations flickered around the circular chamber, each one a testament to the impending apocalypse. Alien representatives from hundreds of star systems sat in tense silence, their most advanced technologies reduced to smoking ruins. "We have one option," announced Chancellor Vorlich of the Zorn Collective, his voice a low, resonant vibration that cut through the chamber's heavy silence. "The humans." The word hung in the air like a forbidden curse. Humanity, a species most advanced civilizations had dismissed as barely spaceworthy, was now their last hope. Jack Hawthorne received the transmission with a mixture of professional calm and barely contained excitement. The Galactic Emergency Council was granting him unprecedented access to failing infrastructure across multiple star systems. It was an opportunity beyond anything he had ever imagined. "This is our moment," he told his team, spreading holographic maps of multiple star systems across the research facility's main display. Each system represented a different technological ecosystem, each with its own complex challenges. The deployment began with surgical precision. Jack's adaptive prototype wasn't a single system, but a framework, a living, breathing technological organism that could reconfigure itself to meet specific environmental challenges. The first test came in the Proxima Centauri system. An advanced civilization's communication network had completely collapsed, leaving billions of inhabitants isolated and vulnerable. Traditional repair methods had failed spectacularly. Jack's team initiated their prototype's primary configuration. What happened next defied every established technological principle. The system didn't just repair the existing infrastructure. It began to reimagine it entirely. Quantum communication pathways restructured themselves. Energy distribution networks adapted in real time. Where alien engineers saw a catastrophic failure, Jack's prototype saw an opportunity for complete transformation. "Incoming data stream," announced Dr. Maya Patel, her voice a mixture of scientific excitement and disbelief. "The system is not just repairing, it's evolving." Alien engineers watched in horrified fascination. The human prototype did something no established technological system could do. It learned. It adapted. It transformed. In the Orion Nexus, another critically damaged star system witnessed a similar miracle. The planetary defense network that had been reduced to scattered, ineffective components suddenly began to reorganize. The human-designed system drew energy from previously unused sources, reconfigured communication channels, and created entirely new defensive mechanisms. Chancellor Vorlich and the Galactic Emergency Council monitored the developments with increasing desperation and dawning realization. This wasn't just a technological solution. This was a fundamental reimagining of how technological systems could function. Jack's team worked around the clock, their prototypes spreading across multiple star systems like a technological immune response. Each failure became an opportunity. Each breakdown transformed into a chance for radical redesign. "We're not just saving these civilizations," Jack explained to his team. "We're showing them an entirely new way of thinking about technology." The most advanced alien analysis teams ran countless simulations. In every scenario, the human prototype should have failed. Its approach defied every established technological principle. Mathematical models proved its fundamental impossibility. But impossibility was humanity's specialty. As the stellar catastrophe continued to rage, Jack Hawthorne's prototype represented something more than a technological solution. It was a declaration, a statement that survival wasn't about having the most advanced technology, but about the ability to adapt, to transform, to reimagine what was possible. "We're just getting started," Jack said, watching as another star system's critical infrastructure began to rebuild itself using his prototype's adaptive framework. The universe was about to learn that humanity's greatest strength wasn't superior technology, but the ability to see beyond established limitations. In research facilities and command centers across multiple star systems, alien engineers began to understand a terrifying, exhilarating truth. Everything they knew about technological development was about to change, and humanity was leading the way. The research facility on Zorn Prime had become a battlefield of technological understanding. Alien engineers worked alongside Jack Hawthorne's team, their traditional neural interfaces struggling to comprehend the human approach to problem-solving. Dr. Krullinx, the lead alien analyst, watched in a state of perpetual bewilderment. What humans called reverse engineering was nothing like the methodical, linear approach of galactic technological development. It was more like technological jazz, improvisational, chaotic, yet somehow producing perfect harmony. "Look at this," Jack said, manipulating a holographic representation of an advanced alien communication network, where alien engineers saw a fixed system with carefully defined parameters. He saw a playground of potential configurations. The most advanced technological system in the Galactic Concordance, a quantum communication network that had taken 3 centuries to develop, was systematically dismantled and reimagined in a matter of weeks. Dr. Maya Patel demonstrated their approach to a group of stunned alien researchers. "Most civilizations see technology as a static solution," she explained. "We see it as a living, breathing ecosystem." Their method was revolutionary. Instead of trying to understand a technological system through its intended design, they deconstructed it completely. Every component, every circuit, every quantum pathway was examined not for its current purpose, but for its potential. An alien communication device that had taken generations to develop was completely reimagined in days. Jack's team didn't just understand the technology. They saw beyond its original purpose, identifying potential configurations that its original creators had never imagined. "This is impossible," muttered researcher Voxa, watching as the human team transformed a complex energy distribution system into something entirely new. The device now could adapt its energy transfer mechanisms in real time, drawing power from sources its original designers had never considered. The psychological impact was as profound as the technological one. Alien civilizations had developed their technologies through carefully controlled linear progression. Humanity approached technological development like a creative act, part science, part art, part pure imagination. Jack Hawthorne stood before a holographic display showing multiple technological systems. To the alien observers, it looked like chaos. To him, it was a complex symphony of potential. "Technology isn't about finding the right solution," he told the assembled researchers. "It's about continuously reimagining what a solution could be." The Zorn Collective's most advanced research teams began to understand the true nature of human innovation. It wasn't about having the most advanced technology. It was about maintaining a perpetual state of technological curiosity. Dr. Elena Rodriguez joined the discussion, bringing her expertise in global systems analysis. "Every technological limitation is just an invitation to create something new," she explained, demonstrating how a complex communication network could be completely restructured using principles borrowed from biological adaptation. Alien researchers watched in a mixture of horror and fascination. The human approach defied every established principle of technological development. Where alien civilizations saw boundaries, humans saw opportunities. A quantum computing system that had taken 3 generations to develop was completely reimagined in a matter of days. The human team didn't just understand the technology. They saw beyond its original purpose, identifying potential configurations that its original creators had never imagined. "We're not improving existing technology," Jack explained to the stunned alien researchers. "We're fundamentally reimagining what technology can be." The most advanced analysis teams ran countless simulations. In every scenario, the human approach should have failed spectacularly. Mathematical models proved its fundamental impossibility. But impossibility was humanity's specialty. As the research continued, alien civilizations began to realize something terrifying and exhilarating. Everything they knew about technological development was about to change. Krullinks watched Jack Hawthorne manipulate a holographic display, transforming complex technological systems with an ease that bordered on the miraculous. "This isn't engineering," the alien researcher muttered. "This is something else entirely." The universe was about to learn that true innovation wasn't about having the most advanced technology. It was about the ability to see beyond established limitations. And humanity was just getting started. The research symposium brought together the most brilliant minds from across the galaxy. Alien researchers sat in a circular chamber, their neural interfaces humming with collective anticipation. Jack Hawthorne stood at the center, not as a conqueror, but as a living embodiment of humanity's most profound technological philosophy. Dr. Elena Rodriguez began the presentation with a provocative statement. "Innovation is not about having the right answer," she said. "It's about asking questions no one else dares to consider." Holographic displays erupted with complex data streams, showing the fundamental difference between alien technological development and human cognitive approach. Where alien civilizations saw technological progression as a linear path, humans viewed it as a dynamic, ever-changing landscape of possibility. Dr. Maya Patel demonstrated the core of human innovation through a series of mind-bending examples. A communication network originally designed for stellar communication was completely reimagined as an adaptive biological monitoring system. An energy distribution grid became a learning algorithm that could predict and prevent systemic failures before they occurred. "We don't see limitations," Jack explained to the stunned audience. "We see opportunities waiting to be discovered." The alien researchers struggled to comprehend the fundamental nature of human cognitive processing. Most galactic civilizations had reached technological plateaus, points where innovation became incremental, where established paradigms became immutable laws. Humanity existed in a perpetual state of technological adolescence, constantly challenging, constantly questioning. Krullinks, the lead alien analyst, presented a comprehensive study of human technological development. The data was mind-bending. While most advanced civilizations showed a gradual, predictable technological progression, human development looked like controlled chaos, sudden leaps of innovation followed by periods of apparent randomness. "Your civilization breaks every established rule of technological evolution," Krullinks said, both in admiration and frustration. Jack's presentation revealed the psychological core of human innovation. It wasn't about intelligence in the traditional sense. It was about a unique cognitive approach that embraced uncertainty, celebrated failure, and saw every challenge as an invitation to reimagine what was possible. The human team demonstrated how they approached technological challenges. Where alien researchers saw complex systems as fixed entities, humans saw them as living, breathing ecosystems capable of constant transformation. A quantum computing network became a playground of possibility. An energy distribution system transformed into a learning algorithm. Communication technologies were reimagined as adaptive biological systems. "Failure is not a destination," Jack explained. "It's a starting point." The symposium attendees watched holographic displays showing humanity's technological journey. It was a path of controlled chaos, sudden innovations, radical reimaginings, complete disregard for established technological boundaries. Dr. Rodriguez broke down the psychological mechanisms behind human innovation. It wasn't about having the most advanced technology. It was about maintaining a perpetual state of technological curiosity. Most alien civilizations reached a point of technological maturity where innovation slowed to a crawl. Humanity remained in a constant state of creative disruption. The most advanced analysis teams ran countless simulations. In every scenario, the human approach should have failed spectacularly. Mathematical models proved its fundamental impossibility. But impossibility was humanity's specialty. Krellink's presented a final, shocking conclusion. Humanity's greatest technological weapon wasn't a specific innovation. It was a cognitive approach, a way of seeing the world that transformed every challenge into an opportunity for radical reimagination. They don't just solve problems, the alien researcher muttered. They fundamentally reconstruct the very concept of problem solving. The symposium ended with a profound realization. The galaxy was about to undergo a technological transformation unlike anything in recorded history, and humanity was leading the way, not through superior technology, but through a unique ability to see beyond established limitations. Jack Hawthorne looked out over the assembled researchers, a slight smile playing across his lips. The universe was about to change, and humanity was just getting started. The Galactic Reconstruction Council chambers vibrated with an unprecedented energy. Where once alien delegates had sat in rigid hierarchical formations, now they clustered around holographic displays featuring human researchers, their traditional power structures completely dismantled. Jack Hawthorne stood at the center of a holographic projection, his presence felt across multiple star systems. The human team had become more than just technological advisors. They were architects of a new galactic civilization. Chancellor Vorlek of the Zorn Collective formally addressed the assembled delegates. "Humanity has proven to be the catalyst of our survival," he announced, the words carrying a weight of humility that would have been unimaginable months earlier. The transformation was total and unprecedented. Human engineering teams were now embedded in research facilities across hundreds of star systems. Where alien civilizations had once jealously guarded their technological secrets, they now begged for collaborative opportunities with human researchers. Dr. Maya Patil led a comprehensive redesign of the Orion Stellar Network, a communication infrastructure that had remained unchanged for centuries. Her team didn't just upgrade the system. They completely reimagined its fundamental architecture. Communication pathways became adaptive living networks. Energy distribution systems transformed into self-learning ecosystems. "We're not repairing," Jack would frequently explain to bewildered alien engineers. "We're reimagining entire technological paradigms." The most profound changes happened in unexpected ways. Human researchers brought more than just technological solutions. They introduced a fundamental approach to problem solving that challenged every established galactic principle. Research facilities that once operated with military-like precision now embraced a more fluid, creative approach. Alien scientists began to understand that innovation wasn't about following established rules, but about constantly questioning those rules. Dr. Elena Rodriguez developed a comprehensive training program that was rapidly adopted across multiple civilizations. It focused not on specific technological skills, but on cognitive flexibility, teaching researchers to see beyond established limitations. The economic impact was equally revolutionary. Technological marketplaces that had been static for generations suddenly became dynamic innovation centers. Human consulting teams were in unprecedented demand, not for specific technologies, but for their unique approach to problem solving. Krellink's, once a skeptical analyst, now led a research institute dedicated to studying human cognitive approaches. The irony was not lost on the alien researcher who had once dismissed humanity as technologically irrelevant. "They don't just solve problems," Krellink's would explain to new researchers. "They fundamentally reconstruct our understanding of what a problem can be." Entire planetary defense systems were redesigned. Communication networks were transformed. Energy distribution grids became living, adaptive systems that could predict and prevent failures before they occurred. The human approach spread like a technological revolution. It wasn't about specific innovations, but about a fundamental way of thinking. Most alien civilizations had reached technological plateaus, points where innovation became incremental and slow. Humanity introduced a perpetual state of creative disruption. Jack Hawthorne's original prototype, The system that had first saved multiple star systems became a foundational model for technological development. But more importantly, it represented a philosophy. Technology was no longer a static tool, but a living, breathing ecosystem of possibility. The Galactic Reconstruction Council's final report was a testament to human innovation. Where previous reports had been dry technical documents, this one read like a manifesto of technological potential. Humanity has done more than save our civilizations, Chancellor Vorlich proclaimed in the final session. They have shown us an entirely new way of understanding technological development. Research facilities across the galaxy began to look fundamentally different. Rigid hierarchies dissolved. Creative collaboration became the new standard. Failure was no longer something to be feared, but an opportunity for radical innovation. Jack looked out over the holographic displays showing multiple star systems, systems that had been on the brink of destruction, now thriving with unprecedented technological vitality. The universe had changed, and humanity had led the way, not through superior technology, but through an unbreakable spirit of innovation. The transformation was complete, and this was just the beginning. 50 standard galactic cycles had passed since the great stellar catastrophe. The universe looked fundamentally different, not because of advanced technologies, but because of a radical transformation in how technological innovation was understood. Jack Hawthorne stood on the observation deck of the Galactic Innovation Center, a massive orbital facility that had become the beating heart of technological development across multiple star systems. His hair was now silver, but his eyes remained as sharp and curious as they had been decades earlier. Dr. Maya Patel joined him, bringing 2 steaming cups of synthesized coffee, a drink that had become a symbol of human innovation across the galaxy. "Remember when they thought we were crazy?" she asked, a mischievous smile playing across her lips. The transformation was complete and profound. Where alien civilizations had once seen technology as a fixed, immutable set of principles, they now embraced the human approach, technology as a living, breathing ecosystem of continuous innovation. Research facilities across the galaxy had been completely redesigned. Gone were the rigid hierarchical structures. In their place stood collaborative spaces that encouraged radical thinking, celebrated failure, and saw every challenge as an opportunity for reimagination. Chancellor Vorlich, now a close friend and collaborator, approached with a holographic report. The Zorn Collective had transformed from a highly structured military scientific organization to a dynamic innovation network that valued creativity over rigid protocols. "We've identified another potential stellar challenge," Vorlich explained. "Where once this would have been a moment of panic, now it was an opportunity for collective problem-solving." Jack reviewed the data streams. Complicated stellar dynamics that would have once seemed insurmountable were now viewed as complex puzzles waiting to be solved. The human approach had become the standard across galactic civilizations. Dr. Elena Rodriguez led a comprehensive educational initiative that had transformed how young researchers across multiple species approached problem-solving. The curriculum focused not on specific technological skills, but on cognitive flexibility, creative thinking, and the ability to see beyond established limitations. The economic impact had been equally revolutionary. Technological marketplaces that had been static for generations now pulsed with constant innovation. Human consulting teams were no longer just advisors. They were fundamental architects of galactic technological development. Krullinx, now the head of the Galactic Innovation Research Institute, presented a comprehensive analysis. The data was staggering. Since the human intervention, technological development had accelerated by over 500% across multiple civilizations. "We don't just solve problems," Krullinx would tell new researchers. "We reconstruct our entire understanding of what a problem can be." The original prototype that had saved multiple star systems now sat in a museum, not as a technological artifact, but as a philosophical statement. It represented more than a solution to a crisis. It was a symbol of a fundamental shift in galactic understanding. Jack looked out over the observation deck. Multiple species worked together in collaborative spaces that would have been unimaginable decades earlier. Researchers from dozens of different civilizations worked side by side, their neural interfaces and communication systems seamlessly integrated. "We're just getting started," Jack said quietly to Maya. The transformation went beyond technology. It was a fundamental reimagining of how civilizations approached challenges. Failure was no longer something to be feared, but an opportunity for radical innovation. Limitations were seen as invitations to create something new. Dr. Rodriguez's educational initiatives had produced a new generation of researchers who saw the universe as a complex, interconnected system of possibilities. They didn't just solve problems, they reimagined what was possible. The Galactic Innovation Center was more than a research facility. It was a testament to the power of human innovation, a living embodiment of a philosophy that had transformed multiple civilizations. Jack Hawthorne reflected on the journey. They had done more than save civilizations from a stellar catastrophe. They had shown the universe a fundamentally new way of understanding technological development. As the galactic sunset painted the observation deck in brilliant hues, Jack smiled. The universe was vast, complex, and full of challenges waiting to be reimagined. And humanity was just getting started.